myself. So I've got this thing called junction tables, and I want to talk very briefly about junction tables. So I don't know how much you know. Has anybody ever heard the term junction tables before? No. I wouldn't have expected that you maybe you might have used them. They're a very strange thing in SQL. So if you'll recall, the way that data is retrieved in SQL is through arrays of dictionaries, arrays of functions. Okay. And then if you think of the way that, kind of pulling off of that, the way that any individual row is stored is that's basically an object. You can think of it as a dictionary. This is their name. This is their combat power. This is their HP. This is their badges. Like you have all these sort of columns that are associated with any individual row of an element. So what happens when you want to do a many-to-many relationship? So the easy thing to think of is like, let's say teachers in classes, right? Like let's say I want to have me as a teacher, and I want to have my students in class 1. And I might have like 30 students, but a different teacher might have 22 students. And another teacher might have 18 or 31 or something like that, right? So approaching this with making a column for each individual student, you could be left with these null columns if you don't fill up all your students. So that's kind of bad. That's kind of bad. So what we're going to do instead, and then, ooh, that's stupid. What we're going to do instead of having potentially blank fields, we're going to do these things called junction tables, and I can bring this up here as an example. I have the code for this on Schoology, and I have it in Sublime as well for you to look at, but I'm going to just zoom into this a little bit. Try to make a simple example over here. I'm making 3 tables for myself. I've got players, I've got badges, and I've got the player badges, okay? So I've got my competitors. I have each, Pokemon player over here. Everybody who signs up for Pokemon gets a new row with their inception date or whatever, and their username, your team that you're on, great. However many of those things. Then there's going to be a finite number of badges that you could do. Compete in 100 battles or whatever like this. I have enumerated basically all of the badges that one individual could get over here. So this is a table. My first table is going to hold my individual players. This is going to hold the badges. And then I have this junction table that's going to associate players with badges. Notice in this junction table, the first thing that should stand out is that I have primary keys in these entity tables, and that I don't have a primary key in the junction table. That's the key thing to look for over here. Anyway, what we do with this thing is that I've got my players here. I've got Paul, Archibald, James, and Leon. And then I have the different badges that any individual could get over here. Visit 100, power up Oshawott 10 times, pay to play, or walk 140 miles in a day. So these are your badges that you can receive. And then this junction table allows just the sort of minimal information that associates a player with the badge here. So for example, what I've got is player 100 has badge 200. Player 100 has badge 201. Player 100 has badge 203. These are not necessarily enumerated in any way, shape, or form, but if I want to add, if a player gets a new badge, I simply add a new row to this guy that has the player's ID and the badge ID. I can add new badges to this system as well. If I want to make a brand new badge over here, I can make badge number 204. Somebody asked me a question about this. Does this make any sense at all? The power of this, thank you for the yes, the power of this is going to be in doing things like the where statement, right? So here, oops. So here I have my SQLite viewer. I have this, however many tables. Oh, 1 table, badges. Why did this not load? Let's load PokéDesk again. Okay, so here's badges. Okay, badges, badges, and players. So players has all the player ID. This is my different players that are inside of there. Sure. These are the badges that they could get. And so what I can do over here with this player badges is you can say select, let's say, all columns from player badges, and you put in the where condition. So like where, let's say PB player is equal to 100. And if I execute this script over here, I've selected all of player 100's badges. If I select this at player 101, I've select all of players 2 badges, et cetera, et cetera. Anything? Yes. 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 I love that you put that together. You can think of this almost as an array. That is basically what's going on here, right? It's kind of like an array, and it's not exactly enumerated like an array, but yes, if you have a problem that you would have solved with an array in SQL, you approach it with a junction table. Yes. So these are not these aren't indexed because they don't have a primary key. So you would basically do your selection based off of your player's ID number. Like I'm looking for this thing. And if you wanted to see, like, let's say the player is let's say there's player 104, there's nothing inside of there. I don't have a player 104 inside of there. I just get an empty set. Yes.
Why make it separate table?
So the question is, why make a separate table? Why not use a separate column? Because this is unknown. Player 1 might have 2 badges. Player 3 might have 40 badges or something like that. We don't want to have separate columns that would be potentially null data for each individual player. I don't want, every time I make a player, I don't want to make like 40 columns that just are null, because that's space inefficient. Yep. Okay, that's a really good question. The other thing about this too is this is extensible. If I want to create new badges in this system where they have columns for each of them, I would have to add a new column for all the players. I would have to allocate all this potentially new memory. Here, I just have this new junction table. It's like, okay, yeah, everybody can get the new badge now. I can adapt to that. Tessa, you had a question. Basically, yeah. Yeah, we can think of this as sets. But when you look at this code right here, like there's nothing about this table that's screaming, this is an array of sets. Like that doesn't, but knowing that I've got these, the way that this is constructed, where I have things that are primary keys, and then these primary keys get referenced in this guy. So other things, just of note, general SQL practice notes over here. Notice that in my tables, in all cases, I'm using different like names, or sorry, different column names. That's just something I do to keep my columns straight. In this case, I called them PID for players. This is collision resistant unique names. BID for badge ID, B name. And then I called this PB player over here, and these were integers. These data types match the data types of the data that they're going to be referencing over here, and we can do more advanced things that will accommodate that. And also, hierarchically, notice that I don't have an overlap between my IDs for my badges and my IDs for my players. So I keep my players are in the 100 range, my badges are in the 200 range. So I'm not going to potentially give an ID of a player. Like it really wouldn't matter if I gave the same ID to a player and a badge if they're in different tables. But I kind of like keeping these guys separate. So I always know, hey, if I see the 200 series, I know that's a badge. I see a 100 series, I know that's a player. You can have these separated by orders of magnitude. You can do a binary. If you really want to do this at scale, you're probably going to use large UUIDs that are unique strings of things, numbers, etc. So this is called junction tables. It's just a skill to be aware of. I'm going to leave it at that. These are some fantastic questions. So with that in mind, the next thing we do then, and you can see this code right here if you want to make it and you want to make your Pokemons. So I have this inner joins, and I'm not sure how much time we actually have today, but I think we can do this. So let me download this guy. So I have some old data over here. I made a table of NFL teams. This is 2 years ago now, and I haven't felt like updating this. But I've got team IDs, team names, team conferences, texts, whenever they were founded and stuff like this. So the question is, when you've got these junction tables, how do you actually get the information, right? Like, how do I get the name of the badge when I had before this, 100, 200, that's not helpful. That's not giving me the strings. How do I associate string 200 with visit 100 Pokestops? How do I get this information out of here next? And the way to do this is to do something known as joins, where we're effectively going to join tables together. We're going to join columns of tables together so that we can create a temporary mega table that's going to allow us to access both sides of the junction table. Okay. So that's where joins are going to come in. So here we go. I've got some NFL data. Here are different teams. My unique identifiers are strings, ARI, ATL, ball, buff. Each of these strings, each of these bits of text is the primary key, so it doesn't need to be enumerated. In this case, it's a string primary key. Their conference, their division, when they were founded, and then their stadium. So Arizona was founded in 1920. They were founded as the Chicago Cardinals, in case you're interested. I think they're the oldest NFL team in the league. And then this stadium over here, notice the stadium, I'm using this 5028, 5020, 50. So this is referencing something that's going to be in a junction table. Okay, these 5,000 numbers, they're referencing the things that's going to be in the junction table. Over here, my stadium ID, primary key. Okay, this feels like entity table because I've got primary keys in here. I've got the name, the stadium capacity, the city, the state, the type of grass, whether or not it's a roof. So here we go, 5,000 series. I totally fabricated these numbers. They have no meaning outside of me. But this stadium has this capacity. 5,002, Allegiant Stadium has that capacity in the year. Yes, do you basically see where I'm doing? I get some, okay. The lethargic nods. We're in agreement. Notice that there are only 30 stadiums in the NFL and there are 32 teams. This is because some teams play at the same stadium. There are two teams that, there are two stadiums that are doubled up. Anyway, here we go. So let's go next. So if I wanted to select, this is the idea of the temporary table over here. So I can have if both of these tables are in the same database, right? So if both tables are in the same database, what I can do is I can select from this database, or I can select from this table, and I can join the stadiums table to this one on the column stadiums ID is equal to teams.stadium. So this is saying where this number is equal to this number, I'm joining these two tables together. Where this table SID is equal to the teams.tstadium, I'm going to join these two together. So now notice that I have my team data and I have my stadium data all together in this same bunch of data. So this was not assembled together. They were separate columns but I did a join to piece these things together. And so this is where we get this notion of relational databases. I'm starting to combine things together. You're starting to combine one table with the other. You interjoin this, where this column is equal to this column. And so it's entirely possible, likely, normal, you name it, to start having fields inside of your tables that reference IDs from other fields. Okay. So here we go. I've got Washington Commanders. That reference table 5009. 5009 was FedEx Field over here in Landover, Maryland. And when was that built? I can't really see from here. I'm sure you could see it on your own. Oh, there we go. Bermuda Grass opened in 1999. And you can do all kinds of other things over here. Questions on this? I'm seeing nods. That's a good thing. Like, this is weird stuff, guys. SQL is weird. It's the weird shouting language that does these arrays in this junction table form. And we, sorry, this is kind of, and you've got these funky statements like this. If this is making sense, that's really good. Here's another one. You can have this multi-line statement. So you can do a partial select. Select the team name and the stadium name. So these are I'm selecting columns from this table. I'm joining this other table on the field. This table.column is equal to this table.column. And all of a sudden, here we go. I've got Cardinals at State Farm Stadium, Falcons at Mercedes-Benz, Bills at Highmark. And you can see both Los Angeles teams playing at SoFi and both New York teams playing at MetLife. So here we go. Where the state is Pennsylvania. Sure, you can do some other selections. You know, you can really begin to whittle this thing down. So what I'm asking us to do today is to take a look at this. We've got these SQLite things, interfaces that you can play with. And there's this one over here. So what I have in my downloads, I just downloaded NFL.db, and I have all the players. This is granted, this is like a couple years old. So this is now 2 years old. But I have all the players, all the stadiums in a table. So you don't have to make the table, and all the teams in this table. And I'm giving you some queries to try to do this, okay? Let's see if we can solve this together with teams problems. Largest capacity. So you can do things like order by. You can select all of them and use an order by. So what would this look like? Select something from teams. And I want you to kind of whittle down the fields as appropriate over here, but use the logic of selects and wheres and joins to find answers to these problems. Does that make sense? I'm going to look for you guys. I'm going to treat this as a green assignment. We have what? How many minutes left? 15, 20? Do we have 15 minutes? 4 minutes? Shut up. I don't know if we can do this in 17 minutes. Can we do this in 17 minutes? Probably not. Let's try anyway. Okay. I'm going to stop recording and we'll see what happens over here. Okay. And we can at least start, and maybe we can try to pick this up a little bit tomorrow. If not, and then we'll lead this in. This is, I think, all that you really need to know to get into the SQL lab. Like, this is the final missing piece of information that allow you to go forward with that SQL lab. This joins. It's the magic sauce.